Okay, this is a titration problem, and the problem reads 35.6 milliliters of 0.55 molar H2SO4 solution are poured into a flask and distilled water is added to give the solution body. KOH solution with a concentration of 0.765 molar is added with a burette until the acid is completely neutralized. What volume of KOH solution is required? It's kind of a long problem, and it turns out there's some things in there that we aren't going to use in the problem. It's just describing the actual process. But if you look at what's given here and what's asked for here, you can see that this is essentially just a stoichiometry problem. So the familiar parts to a stoichiometry problem are to write and balance an equation and then change the given thing to moles. And since this is all done in solutions, that'll be with molarity. And then we'll use the mole ratio from the balanced equation and finally change back to what we're asked for, again using the molarity equation. All right, so let's go ahead and set this up. Here's the problem, and I've gone through and kind of edited out some of this stuff that was unnecessary in it. So we are going to react H2SO4 with KOH. So it's a neutralization reaction. The products of a neutralization reaction are always water and a salt. The salt in this case, let's do the complete neutralization. It says completely neutralized, so that means that we're going to get K2SO4 as a product. Remember, that only one hydrogen comes off of H2SO4 in the first ionization, but if we completely neutralize it, we'll take both of them off. Now you may have noticed this is not balanced, so to balance it, we're going to need a 2 there, and we're going to get 2 waters out of that. We can't skip this step because we're going to need that as that third step. So the next thing we're going to do is we are going to find the number of moles of given. So I'm going to take this 35.6 milliliters. I'm going to multiply it by 0.55, and instead of writing big M, I'm going to write moles per liter. But we can also do this, and I've done one like this before. If we put an M in front of that, it'll be millimoles per milliliter, and that way we won't have to make any conversions. So when we multiply those two together, this works out to be 19.58 millimoles, and that is of H2SO4, H2SO4. All right, so then there's the number of moles. Next we're going to use the mole ratio, so that 19.58 millimoles of H2SO4 times the mole ratio, which is 2 moles KOH per 1 mole of H2SO4. Right, so when we take that 19.58 times 2, we're going to get 39.16, and that is millimoles of KOH. And then finally, we're going to take that 39.16 millimoles of KOH. All right, in order to get the units to work out, we're going to need to divide it by the given molarity, which is 0.765 millimoles per milliliter. And I do that so the millimoles cancel out and the milliliters will go up on top, because when we invert that, we multiply. And so when we divide this 0.765 into 39.16, we get 51.19, and that's in milliliters of KOH. So again, just a stoichiometry problem with the same 4 familiar steps.